Hello and welcome to STEM Decoded. This is the part 2 of functions and its transformation. In part 1, we discussed about vertical translations or shifts that happens when we add or subtract something from the output of the function. If you haven't watched part 1 already, you can visit by following the link somewhere here. In this video, we will learn about horizontal shifts. So without further ado, let's begin with the video. So in the last video, we saw a function which was fx is equals to x squared, and we found out the values of x from -3 to 3, and then plot the function fx over this plot here, and we got a curve that had its point of coincidence at 0. Now let's just go ahead and change our input of the function as fx plus 1. Right? And so our output would become x plus 1 whole squared. And now let's name this function fx as mx. So mx is equal to fx plus 1, which is equal to x plus 1 whole squared. So we will see that here our input x will also change. So we will start from -4, -3, -2, -1, 0, 1, and 2. And let's try to find the value of mx here. So -4 plus 1 whole squared will be equal to -3 whole squared, which will be equal to 9. -3 plus 1 whole squared will be equal to -2 whole squared, which will be equal to 4. -2 plus 1 whole squared will be equal to -1 whole squared, which will be equal to 1. -1 plus 1 whole squared will be equal to 0. 0 plus 1 whole squared will be equal to 1 whole squared, which will be equal to 1. 1 plus 1 whole squared will be equal to 2, which will be again equal to 2 whole squared, which will be 4. 2 plus 1 whole squared will be equal to 3 whole squared, which will again be equal to 9. So we're starting from 9 and we're ending on 9, but we see that our x has now shifted to -4 from -3 and it ends on 2. So now let's try to plot this graph here. Okay, so now let's try to plot our graph. At -4, the value is 9, so it will go somewhere here. Then at -3, the value is 4, which will go somewhere here. Then at -2, we have the value 1, which will go somewhere here. Then at -1, we have 0. Then at 0, we have again 1 again, so somewhere in between here. Then at 1, we have 4. And at 2, we have 9. It will come here. Now let's try to plot this. Okay. So now let's try to see the difference between this particular graph, which is of mx, which has input as x plus 1, and here where the input is x. So we see that the point of coincidence was in here, x is equals to 0 and y is equals to 0. While we see that at the bottom, the point of coincidence now becomes -1, which is the point of coincidence, and it is x is equals to -1 and y is equals to 0. So we see that the graph is now shifted to the left by the numbers we add into it. So whenever we add something into the input, our graph shifts to the left. And now, what do you think would be the result of another graph that we plot, which is kx, and where kx is fx minus 2? What do you think? So we saw that when we were adding +1 to the input, the graph was shifting left, the graph was shifting left. And now if we do -2 into the input, we think that the graph would shift to the right. And this is called a horizontal shift. Okay, so now let's try to plot this particular graph fx minus 2. So fx minus 2, and as we have the function fx minus 2 as x squared, and now our x is x minus 2, so it would be x minus 2 whole squared, and this is the new function kx. Let's try to find the value of the function here. So we'll start from -2, -1, 0, 1, 2, 3, 4. And now let's try to find the value of kx here. And by -2 will be equal to 4, -4, which will then be equal to 16. Then we have for -1, -2, which will be equal to -3 whole squared, which will be 9. 4 - 2 will be 2 whole squared, which will be 4. Okay, basic algebra, we found the value, and let's try to plot this graph now. Now let's try to plot this. At -2, we have 16. So on the very top, at -2, we have 16. At -1, we have 9, which will come around here. At 0, we have 4, which is this. At 1, we have 1, somewhere here. At 2, we have 0. And at 3, we have 1 again. At 4, we have 4. When we see that the graph can now go, we can just follow the pattern, it can go up like that. So we see that the graph is now shifted. The point of coincidence now is +2, and the graph has shifted right by 2 units. And this might seem a little confusing, because adding 2 seems like the graph should shift right, and subtracting 2 should seem like the graph is shifting to the left, but it's the opposite. And that's because x plus 2 is equals to 0. So x is actually equals to -2. And that's why it's shifting -2 to the it's shifting to the left. And when we are doing -2, it shifts to the right, because x minus 2 is equals to 0. So x is equals to 2. So this is the real, this might be confusing, but you can always remember it by making it equal to 0. Okay, so now a bonus question from what we have learned about vertical and horizontal shifts. So till now we are done with 2 shifts. We are done with vertical shifts, and we are done with horizontal shifts. So we saw that when we added something into the output of the function, if we added into the fx any number n, for example, and if we subtracted anything from the number n, adding it would make the graph shift n units up, and subtracting would make the graph shift n units down, right? And if there was a horizontal shift, so we change x by positive or negative numbers, and when we change x by a number n, and we add the number n into it, the graph shifts towards the left by n units. And if we subtract something from the input, then the graph shifts towards the right by n units. Okay, so now that we know this, can we conclude what would the transformation to the function fx is equals to x squared, which we are dealing with right now? What would the transformation fx minus 4 plus 2 becomes? Can we conclude this? Can we find the answer to this question, that what would happen to fx minus 4 plus 2? So we know that when we subtract anything from the input, which is here, when you subtract anything from the input, it actually shifts the graph to the right by those many units. So the graph would shift right by 4 units. And as we are adding something into the graph, and we see that when we add anything to the complete output, the graph shifts upwards by those units, and it would shift 2 units upwards. So now that we know that, we can easily make the graph, and we can plot the graph, and we understood shifting, which was vertical and horizontal shifting. So this was it for today's video. And in this video, we concluded horizontal shifts, which happens when we change, add, or subtract something into the input of the function. Now in the next video, we will learn what happens when we multiply or divide something, and what are those shifts called. So that's it for this video, and if you want to learn more about shifts, make sure that you subscribe to the channel and watch the next video, and do like and subscribe. So that's it for this video. Thanks for watching.